Hi guys, in our class we learned the definition of relations and its functions. So we also learned that on here we know that we have two sets, and we have set T and set X, and in set T we have 1, 2, 3 ordered pairs. Same thing with set X having 1, 2, 3 ordered pairs. Now, let's go ahead and review once again how to find the domain of, let's talk about set T, okay? So we're looking for the domain of set T. Let's see. Now, we all know that domain is just the x values, while the range are the y values. So in here, if we take a look at every ordered pair, our domain will be 2. 2 is the x value of the first ordered pair. For the second ordered pair, we got 3. And the last one, we have x. So I would say that, 8. So I would say that 2, 3, and 8 are the domain of the relation of the set T. Now, while for the range is basically the y values, and we're going to start with 5 for the first order pair, next 4, and another y value is -1. Here we go. Now for the range of set T, we got 5, 4, and -1. Once again, for the domain, we're talking about the x values 2, 3, 8, and for the range, we're talking about the y values 5, 4, and -1. Now this time, I want you to challenge yourself by finding the domain of set X. I'll give you 5 seconds to do that. Okay? Now find the range this time of set X. Okay, now did you get 3, 4, and 3 for your domain? If you got it, then you're right. Now for the range, you should have gotten 9, 8, and 5. That's going to be your range. Now, in our class, we learned that to determine if the relation is a function or not, first is you must identify your domain first. Now here in the first in the set C, we got 2, 3, and 8. Now for the domain 2, 3, and 8, we agreed in our class that in order for a relation to be a function, there should not be repeated domain or repeated x values in a set or in a relation. So now we got 2, 3, and 8, and none of them are repeated, so we can say that this is a function. Okay, let's try set X. We got 3, 4, and 3. Here we go. So as you notice, guys, we got 3 and 3. They're both repeated. So they are repeated. 3 is repeated. So we can say that it is not a function. Okay, we don't really care about the y values, the range, in identifying if it's a function or not, because we all just have to look at the domain, at the x values. Now, how about if the graph is given? For example, here we got 4 graphs. Now we'll go ahead and use the vertical line test. Now, in our class, we learned that in order for us to figure out whether if a graph is a function or not, is by the use of a vertical line test. Vertical line test is you draw a line in any part of the graph, and if the vertical line touches the graph at exactly one point, then the graph is a function. So let me use this blue marker. I'll go ahead and draw a vertical line on the left side of the graph, and it looks like the vertical line touches the graph at just one point in the middle. 1 point on the right side, 1 point. So I would say yes, it is a function. Yes, it is a function. Now, how about here? Oops, we got 2. So it is not a function. How about in the middle? Okay, so we got, we can say that the vertical line crosses the graph at exactly 1 point. But, so this makes this graph a function. But the problem is, when you draw a vertical line on the left side, it's going to touch infinite number of points. Here on the other side, it's going to cross the graph at infinite, points also. So it is not a function. Let's try this. 1 point, it crosses 1 point, and the other one crosses 1 point. So yes, it is a function. So we can say that using the vertical line test, graph 1 and the last graph are both functions, while these two, the middle ones, are not functions. Now, I remember we were doing this. Okay, this one. I remember we have, we were solving for functions. So we agreed that, let's say for example, we have -3. Okay, and the function of x is -3. Now we agreed in our class that the -3 is inside of the parentheses, while the other -3 is outside of the parentheses. So for example, number 1. For example, we have the function of x is equal to 2x squared minus 5. Now, let's say we have this. Let's say we have, there you go, that. As you notice, we got -3 inside. When the number is inside of the parentheses, that means we just have to plug it in to the to x. That means, okay, that means we're gonna change that to -3, and then we're gonna plug that -3 to x, and here we go. So because -3 is inside, we're just gonna plug in -3 in here, and now we have, okay, first in doing this, we can easily use a calculator to solve this one. But if you use your mental math, we're going to apply the parentheses first, which is -3, and then exponent, and now we have 2, -3 times -3 gives you 9 minus 5, and now here we go. So here we get 18 minus 5 should give you 18 minus 5 is, what is it, 13? Okay. So this is the answer if -3 is inside. Now how about if you have, okay, let's have number 2. Use this one now. How about if you have number 2, the function of x is equal to 2 minus x over 5, given the function of x equals 1. Okay? Now as you notice here, for example number 2, your 1 is outside, your 1 is not inside, so your 1 is outside of the parentheses. So that means we're just going to copy 2 minus x over 5 equals -1. So the entire function should be equal to -1. Now because we are solving for x this time, See that minus equal 1? We're going to make it over 1 because we know that every whole number has a denominator 1. Now, the reason why I made it 1 over 1 or a fraction is because I know I can easily cross multiply them. Other students would multiply both sides by 5, but because a lot of my students, a lot of you guys can cross multiply, so we'll go ahead and do cross multiplication. So here we go. So multiply 1 to 2 and 1 to negative 2. Well, we all know that if we multiply a number by 1, the product will always be the number itself. Here we go. 5 times 1 is 5. Now we're solving for x using your algebra swag. We're going to move that 2 over, becomes minus 2. Now here we got negative x equals 5 minus 2 is 3. Divide both sides. Now the reason why we're dividing both sides by negative 1 is because we do not allow an equation to have a solution to have a negative x. So we're going to make it positive by dividing both sides by negative 1. So now we have x is equal to 3 divided by negative 1 is negative 3. If you think I'm going fast, I suggest that you pause and try to go over the problem. And I guess that's about it. Thank you.